All right, then without further ado, I would like to have another presenter. For each presentation, the speaker will have about 10 minutes time, and then there will be a question and answer allocated after that for about 5 minutes. Now after the very first presentation, we have the next one conducted by Dr. Assistant Professor Feng from SIT. Now please welcome the next presenter.
Thanks, the chairman, for the introduction. My name is Elsa. I'm assistant professor with the engineering cluster of Singapore Institute of Technology. And my research specialization is in energy storage applications and data-driven applications for power systems. And today I'm going to present our paper. It's a review paper on maritime electrification. In this paper, we have covered an introduction, a landscape introduction to different aspects of the marine electrification, including electrification technologies, which are the fundamentals for electrification for the ships, and also charging infrastructure, which support the electric vessels and energy management strategies that optimize the operation. Along with the title, these are the table of contents. First of all, I will touch on the fundamentals of the electrification technologies and also onboard and onshore charging infrastructure. And then last is the energy management strategies. Okay, so these technologies actually have been used in traditional power industry for many years, and I think among them, energy storage systems such as the lithium-ion batteries are the most well-known kind of electrification technologies that can be integrated with electric vehicles and also electric vessels. And there are others, including photovoltaic panels, which can be integrated as part of the electric vessels on the surface, on the roof, that can help to harness the energy from the sun. However, there's a caution with these energy sources that they are intermittent in nature. So they are usually paired with energy storage systems to ensure the intermittency is mitigated. And also hydrogen fuel cell, which is a type of energy source that can convert the chemical energy in the hydrogen to electrical energy, and have been widely used in electric vehicles and other applications in power industry as well. They are quite fast in refueling. You can just replace the tank for recharging. And to integrate the different kinds of electrification technologies, there are different categories of electric vessel configurations. The traditional configuration is just to burn the fossil fuel and then power up the propulsion system. And diesel electric, which is instead of using the engines, we use electric motors to drive the propulsion, but it's still burning fossil fuel. And also we have hybrid, which is pretty much like the cases in electric vehicles. There's a hybridization it's a mix of diesel propulsion and electric motors. And there are two types. One is battery hybrid, the other is battery plug-in hybrid. The difference is that the latter has the option to be charged from external chargers. And also the last is, of course, the full electric, which is running purely on the electricity. Yeah. However, this kind of configuration is still pretty much limited to shorter distance vessels rather than global, bigger cargo shipping. Charging infrastructure. So if you think about the process of the charging, essentially what it does is that it channels the AC power from the power grid to DC power to be stored in the batteries. So you have to do this AC to DC conversion, and these devices that does the conversion from AC to DC, they are usually bulky and big and heavy. And if you're thinking about placing them on the ships, it's pretty much like the case for the AC charging system. So you are basically placing the AC-DC conversion on board, and to do this conversion. Whereas for DC charging stations, we are moving that device, the AC to DC conversion device, out of the vessels onshore and place it onshore. So in doing so, we have the potential of saving the space and the weight on the vessels. And also, there are two types of onboard systems. It's either running on the AC main bus or the DC main bus. In terms of the interfaces of the charging infrastructure, that they can be categorized largely in three categories. The first is the contact charging, which is by its name, is charging the batteries on board through different kinds of plug designs, either can be manual or automatic. And wireless charging is basically kind of wireless power transfer through electromagnetic induction. You have one coil on the ship, you have one coil on the charging infrastructure, and then through the electromagnetic induction, the power is transferred wirelessly. And battery swapping, so by the name of it, is basically just swap out your used batteries on vessels and then place new ones in it. And this kind of technology has the potential of harnessing renewable energy, because you would have these large battery banks to stand by for swapping, and then you can integrate these battery banks with renewable energy, or you can also make use of the lower prices during the day to charge up the batteries. So there are a lot of potentials in this kind of technology. However, they are quite expensive, because you need to have this large bank of battery to begin with. And charging infrastructure control, so largely can be categorized into two. The first is the low-level control, which is basically referring to the converter controls. We use what we call the pulse width modulation to control how much power and when does it go into the batteries. And this low-level control, they are receiving the commands from the high-level control, which is an overall energy management system coordinating among different parts of the ships and onshore systems. Okay, so lastly is the energy management strategies. So if you think about electric vessels, essentially it's a small power system. It's an onboard small power system. So the planning and operation of it is pretty much like what we do for a traditional power system operation planning or microgrid planning. So I would say the first step of operating any kind of power system or microgrid is to decide on the optimal sizing. So this means what kind of components do we choose, and what is the power rating for all these components that we want to put on board. And based on this optimal sizing, we can then develop operation strategies that can achieve various purposes. This is pretty much an optimization problem that can be formulated according to the need of the operator. So in one of our own publications, reference 19, we have designed a onboard energy management strategy for our for the electric vessels, which is in which we treat the vessel as a small power system, and we formulate the problem to reduce the operating cost while considering the uncertainties from the PVs, from the weather, from also the tidal waves, and then. There are also other purposes that we can consider, such as to reduce the fuel consumption or greenhouse gas emission. And of course, this, as I mentioned, is an optimization problem that can be formulated according to the need of the operator. Okay, so that is all for my presentation. Here are the references that we have covered in this review paper, and you can refer to our paper for reference. Thank you.
Hello? Hi. Thanks a lot for the presentation. All right. Any questions? All right.
Thank you very much. Very insightful again. Can I make an assumption you've been to Energy Observer? The
Sorry?
vessels sail around the world. purely not a single drop of oil being used. Right now, currently, alongside 1 degree and 15-minute marina. Are you on board? No, okay, no problem. Okay, the actually leading question to that is they use wind. And the wind sails they use one is apparently, you remember correctly, is ocean wind. And there's a lot of lesson learned for American Cup sailing. That's why my question is, could wind be part of the feature instead of just solely on solar panel in the electrification aspect of it?
Sorry, I didn't hear your question
Okay,
clearly.
my question is, could wind, besides solar panel, could wind be part of the feature in the electrification, the whole overarching system point of view?
So how do we view the solar PV in the whole landscape of
No,
electrification?
yeah, correct. In addition to solar, wind.
Meaning wind power, right?
Yeah.
Using wind.
So how do we view it? Do you mean?
Could wind be part of the feature in the overarching on the electrification system, whether on board the craft or on the shore charging or the float charging?
Oh, of course, it can be integrated in different parts. You can integrate it part of the ships, which I have seen, and also you can integrate with the charging infrastructure together to support the. You can have these onshore batteries, which can store the PV generation, and then use it later to charge the electric vessels.
Okay, I've been motivated by the Energy Observer. I think it's the only vessel right now in the world, sail around the world, and not a single drop of oil being used. And they use hydrogen, they use, as usual, the normal thing. But the one thing, two unique thing beside the hydrogen is a sail, they're using the wind. When they're moving, they're also charging thing, because as you know, you can do the hydro aspect of that. Just a comment, since I hear from you, thank you very much.
Okay, thank you. Thank you for your question.
Okay, there is one question on Pigeonhole. Maybe you can also see the weight of electrical system is comparatively heavy compared to a hydrogen system as per recent claim by Energy Observer. Okay, again, it's about Energy Observer. What is your take on this?
The weight of the electrical system is comparatively heavy compared to, which means to say the hydrogen system is lighter? Yeah, so I think the thing about hydrogen fuel cell is that it's kind of like something that people talk about a lot when it first was adopted, but it never really take off that much. In the electric vehicle industry, it was, I think most of it comes from the cost of the hydrogen system. The hydrogen, even they are quite fast in refueling, they are quite hard to source. You have to build up a whole supply chain that can supply the hydrogen from the point that is produced to the point that is consumed. And another thing is a question that people usually ask about hydrogen. So basically, if you want to produce hydrogen, you have to use electricity to do the electrolysis process to produce the hydrogen. But instead of doing that, why don't you just use electricity to power up the vehicles? So this is the question people always ask. Why do you have to have this interim process of converting electricity to hydrogen? Yeah, so it's, how to say, is the weight is only one aspect. There is more important things to consider, which is the energy density. Energy density is very important for all kinds of electrification applications, especially in the transport industry. You have to make sure that with this limited amount of weight and volume, you are able to provide a very high energy density kind of storage. Yes, that's my
Thank you.
take.
Thank you.
I just had one question. I'm Shiva from BMT. Thanks, Elsa, very interesting presentation. My question was about the induction method which you explained. Normally for ships, especially in terms of port operations, turnaround is always a big issue. So do you have any comments on the induction type in terms of the turnaround? Because I would presume that it would take a longer time, considering that the energy flux which is transferred would be much less compared to direct charging?
So you mentioned, are you asking about the induction charging,
Yeah,
wireless charging?
wireless charging in terms of, say, vessel turnaround, because charge times are important. So I
Okay.
would presume it would be very high, right?
Okay, first of all, I want to say that induction charging has been actually used in a lot of industry, like our phones and also electric buses. I've seen that, I actually have seen one of those induction charging device in one of the bus charging station in China, and it's very impressive. So they just have to park the bus above these coils, then it can get charged. And in the maritime industry, of course, it also has this advantage of lesser exposure, right? Because you can have the coils placed inside the charging device and the vessels, so you are not exposing these coils to external environment. In the maritime, it's quite harsh. It can cause damage. But if you think about scaling up, which means if you want to step up the power rating and to increase the charging speed, the coils need to be really large to realize that transition, the transfer, the power transfer. So then it will mean heavy and bulky on board as well. So there's a, a compromise between the power rating and the space that you can set aside. Yeah. So I think nowadays it's still more commonly used is the wired charging, right? The either DC or AC charging. Yeah.
All right, thank you. So then I think this is the end for the question and answer session for this part. Thanks a lot.
Thank you.
Thank you.
Jasmine.